Okay, so basically for this whole error thing, the main point you want to take away is this right here, this equation. This basically just means the absolute value of your result is going to be less than a sub n plus 1. Okay, so for example, on the WebAssign, I can show you. So their error on the WebAssign was, let me copy this. Their error was less than this number, whatever they had. So basically, when we are doing the error for the WebAssign problem, you are first, in order to do these errors, you have to show that the series you're doing the error for is convergent by the alternating series test. So for example, for this one, we have -1 raised to the n plus 1 over n to the 7th. It's alternating series, so you have to, for it to be convergent, you have to check the limit if it equals 0, and then I just did a quick comparison to show that it converges. And these are the two things that you basically have to check to see if it converges, because you can only do this error thing if the series converges, which makes sense. Basically, what they want you to do is they want you to show that a sub n, or your absolute value of r sub n, is less than a sub n plus 1. So your result, absolute value of r sub n, is less than a sub n plus 1. On the WebAssign, our a sub n is 1 over n to the 7th, but we want a sub n plus 1. So what we're going to replace this n with is going to be n plus 1 to the 7th. So that is going to be 1 over n plus 1 to the 7th. And then basically from here, you're going to have n plus 1 to the 7th, but your result is going to be less than what this n plus 1 to the 7th is, but this is also going to be less than your error, which is right here, which is, I mean, not your error, but whatever they give you. So that's going to be 0.00005. Since we're finding the result, all we really have actually is we can drop that, because that's what we're actually finding out. We're just saying that the result is going to be less than that, and then is going to be less than the middle term, and then this middle term is going to be less than whatever they give us. So we have that right there, and then we can put that less than 0.0005. 1 2 3 1 2 3 4. Oh, one more 0. So basically from here, all you're doing is, you're going to need a calculator for this. You're not doing this without a calculator, just saying. So basically what we're doing here is, since our series goes from 1 to infinity, we're going to plug in numbers starting from 1, and we have to see, like, when you evaluate this equation right here for numbers that you plug in, you have to see, like, you have to get as high as you can without going over this number right here. So for example, that it ended up being, the answer was 4 terms, because if you did 4 terms, that means n equals 4. That's what 4 terms mean. So you have 1 over 4 terms. That would be, okay, yeah, so 4 terms. That means n equals 4. So you had 4 plus 1 to the 7th, which is equal to 1 over 5 to the 7th. And this is approximately, obviously use your calculator here. It actually gave me in like scientific notation, and then I had to convert it on Desmos. So that's 1, 2, 3, 4, 5. So it gave me, on Desmos, it gave me, when I did it, it gave me 1.28 times 10 to the negative 6th. But this is equal to, you just move the decimal places 6 places to the left, so that'd be 1.28. 1, 2, 3, 4, 5, 6. So right there. So that's equal to 0.0000128, and that's less than 0.00005. And you could also, if you would check, if you did 5 terms, it would be 1 over 5 plus 1 to the 7th, which is equal to 1 over 6 to the 7th. And if you did that, this would be greater than this error over here, 0.00005. So you're gonna stop here. So it's basically, your answer for that WebAssign is 4 terms, because if you did 5 terms, you would have 5 plus 1, 1 over 6 to the 7th, and whatever that decimal approximation is, it's actually greater than then the condition that they gave you earlier, your error has to be less than this number. So you stop at 4 terms, you don't go to 5 terms, because that will make this inequality false. It won't be less than that number. It would actually be greater than if you did 5 terms. And yeah, that's basically what this whole error thing is. The main point is you take a sub n plus 1, put it less than whatever error bound they give you, and then you basically do the whole process of plugging in numbers from 1 to infinity. Like, you keep on going up until you go up as high as you can with your number being less than this, but you don't want it to be greater than that. So whenever you stop, if it's less than that, and the next term, if the next number you plug in is greater, then that's how many terms you're going to have. So my question on the website, it was 4 terms. For this one, I don't really know where you would stop, since we can't use a calculator. I don't, like, if this shows up on a test, I don't know like where we would stop if we can't use the calculator. But yeah, that's all you need to do for these type of problems.